Hello everyone, welcome to PACE Digital. This is Charita Shankar from PACE Hyderabad. Today we are going to go with yet another video of the vectors, that is the part 2. The lecture 1 problems is what we have already completed, and this is the lecture 2 which we are going to release now. Right, so I have some questions, some set of some 40 to 50 questions is what we are going to solve in this class. So the continuation of the previous, whoever did not watch the previous lecture 1, please do visit that and come to this video. Right. Now going with the question number 13. It's a continuation of what we have already completed, right? Now question number 13 is what, yes, we have done. Now 14th question is what I'm supposed to go with. Yes, in the previous video, we have already completed question number 13. Now you are given vector A plus vector B is greater than vector A minus B taken under mod, their magnitudes. What is the angle between A and B is my question. So for looking at this inequality, I don't have anything to do other than taking squaring on both sides, right? So just to take squaring on both sides, what do I end up with? A square plus B square plus 2A dot B vectors, okay, greater than, here also A square plus B square minus 2A dot B. Right. Now, these both gets anyhow cancelled when they are transposing to the other side. Now, 2A dot B minus 2A dot B comes here as plus 2A dot B. That is a 4A dot B is greater than 0. Right. So, which means A dot B is strictly greater than 0. And what is A dot B? A dot B is cos theta times mod A mod B, isn't it? Because we know that cos theta is A dot B by mod A mod B. So, A dot B is mod A mod B cos theta, which is greater than 0. When mod A and mod B anyhow, that is the length or that is the magnitude what we are talking about of vector A and B. Hence, they are anyhow positive. The only thing left over is a cos theta which is greater than 0. And where is cos theta greater than 0 when I'm talking about just the first and second quadrants for vectors or the straight lines? It is only cos theta is greater than 0. It is only in the first quadrant. It is not at all in the second quadrant. Right. So first quadrant angles are all less than 90. Right. So less than 90 in this is they are acute. That's it. So your option for the 14th question is option C, that is they are acute angles. So it forms an acute angle between the angle A and B. Theta is the angle between A and B. That's it. Right? Now going with the next question, 15th question, what's given? Understand there carefully. Now 15th question, you are given a curve. And what is that curve? They said y equals to 8 by x square, a point x1, y1. A tangent to this curve at the point where x1 is 2. Tell me when x1 is 2. Just substitute x1 2 here. So 8 by 2 square, 8 by 4, that is 2. So tangent at this point is what I have to figure out what that is. Now the tangent cuts x-axis at point B. So for that I need to understand what's a tangent. Tangent is same as writing dy by dx, which is, what is dy by dx here? That is 8 times basically this is x to the power minus 2, isn't it? So minus 2 differentiation, that is minus 2 times x to the power minus 3. That is minus 16. Yeah, so that is minus 16 upon x cube. Now what is the slope at the point 2 comma 2? That is minus 16 upon 2 cube, that is 8. So hence minus 2 is the slope. Now, what is the equation of tangent with the given slope and the point 2 comma 2? That is y minus y1 is m into x minus x1. So, y minus 2 plus 2x minus 4 comes here as plus 4 equal to 0. So, this is 2x plus y plus 2 equal to 0 is the equation of the tangent, what we have. Now, what's the question? They said the tangent cuts x-axis at point B. So, if it is cutting x-axis, obviously its y length is y value is 0. So, what is 2x equal to? Minus 2, which means x equal to minus 1, right? So, now what's the question? So, x equal to minus 1 comma 0 is the point B that they are talking regarding. Then the scalar product of vector AB bar and OB bar, right? So I am given vector A. What is the point A that they have already mentioned? That is x1, y1. That is my 2 comma 2, right? Now the question they are asking for is scalar product of AB bar and OB bar. So AB bar is obviously OB minus OA, right? And your OB bar is same as your minus 1 comma minus 1 comma 0. That is minus I here. And here OB bar, that is minus I, minus OA bar, that is 2I OA bar. Yeah, so when I am talking about, yeah, O is nothing but your origin is what I can take the position vector from there. Right, so 2I plus 2j. Finally, this is resulting in minus 1 minus 2, that is minus 3I, next minus 2j bar, right? IJK bars notation, please. That's mandatory. Minus 1 minus 2, that is minus 3I bar and minus 2j bar. Now my question is, what is the scalar product of the vectors AB bar and OB bar? So for this and for this is what I have to take their scalar product. That is just A dot B. Just multiply their I coefficients, that is minus 3 times minus 1 plus 0 only, which will be ending up with 3 as your answer. So option A will be your right choice there. Now going up with the next question, number 16. Right. For the 16th question, your A, B are given to you. Which of the following points lie? 16th question is what I think we've already completed in the previous video while we are dealing with angular bisectors. So please do watch that. Right. For question number 17 now, if a vector of A of magnitude 50 is collinear with B. See, there is a vector A of magnitude 50 is what they are telling us. I don't know what is that. That is xi plus yj plus zk is what I will take. If it is a unit vector, obviously x square plus y square plus z square under root will be equal to 1. And they wanted a vector of magnitude 50. So this times 50 is what the A vector is. That's how I notate my A vector. That is my A vector. It's got magnitude 50. And they said this is collinear with vector B. That is 6I minus 8j minus 15 by 2 k bar. Right. And makes an acute angle with positive x-axis is what they are telling us. Then what is the relation is what my question is. Right. So how do I think about this question? Right. So your A vector and your B vector is given to you and makes an acute angle is what they said. Acute angle in the sense cos theta should always be positive. Right. Cos theta is A dot B. That is always positive. Right. Right. So when they said in the question that vector A, vector A of magnitude 50 is collinear with vector B. So can I say A equal to some T times B bar? When it is collinear or parallel, I can always say A bar is T times B bar, right? Apply the magnitude there. So magnitude of A bar is T times magnitude of B bar. Magnitude of A bar. So A bar, they said vector A is of magnitude 50 is what they have given. So 50 equal to T times. This is under root 36 plus 64 plus 225 upon 4. So what will be the answer here? That is T times under root. This will be 100 into 4. That is 400 plus 225. That is 625 upon 4. So you will be ending up with 50 equal to T times 25 by 4. So from here, what is your T value equal to? So T is 50 times 4 by 25. All right. So T will be equal to 8. Okay. So, but now what is the question they are asking for? Where are we? Where are we? Where are we? Yeah. So my A vector is what I got it to be. What is my A equal to? Vector A. How do I represent that? So vector A is 8 times B bar, that is 6I minus 8J. Uh-oh, please keep writing. Yes, minus 15 by 2 into K bar. Right. Okay. Now what is the question? This makes some acute angle with the positive x-axis or z-axis? Yeah, that is z-axis there. Right. Oh, yeah, there is a small correction here, I guess, isn't it? Oh, yeah. Let me erase this and write it for you again. Right. So that is 25 by 2, isn't it? 25 by 2. Right. So 2 times. So T will be 4. Right. So what is my A bar? That is 4 times 6I bar minus 8J bar minus 15 by 2K bar. When you resolve this, A bar equal to 24I minus 8 fours 32J bar minus 30K bar. Right. So and now what is the question demanding us? So we have got vector A is 4 times so and so. That's absolutely fine. Vector A is, I can say vector A is 4 times. Is this all my vector B? Fine. But now think about, they said another condition. Why do you think they have said that? Makes an acute angle with the positive z-axis, right? So if I'm talking about z-axis, z-axis, how do I represent? Is it 0 I bar plus 0 j bar plus k bar? Isn't it? Right? So they said with the positive x-axis, it is making this vector A is making an acute angle with vector B, in the sense when I take the dot product, it should be positive. So dot product positive undalante when this is, see these two places anyhow, I and j components will be 0 nullified there. When you are multiplying the k component with the k component there, you are supposed to get a positive, right? Only then your angle is positive. Cos theta should be positive only. So negative into positive can't be a positive value. We want a positive value, but I have a minus 15 by 2 there. So what do I do now? I just take a negative sign common. A equal to minus 4 times, that is minus 6i. I just take a minus 4 common there, right? So, or else if you just multiply with the negative sign, there you can solve the problem, right? So what I say is my A bar is minus 4 times B bar is what I can take. Then this negative will automatically turn to be a positive value, isn't it? Right? Got the situation there? As they said, it's making a positive acute angle is what they said. When you multiply their A dot B should always be positive. And how can you get that positive? Only z-axis, yeah, obviously you'll have a positive direction, hence they said that will be positive along with this negative. You cannot get a positive value unless you make that negative positive by taking another negative sign there. Hence, your A bar is minus 4, B bar will be your option there for the question number 17. That is option B is your right choice, right? Next, going ahead with the 18th question there. So what does that state? You are given A, B, C if the vectors constitute the sides. See, understand in the vectors chapter, you don't know whether the given vectors are points, that is the position vectors, or the original sides, that is the vectors. Okay. See, it is just like a pond wherein you find a lotus there. Okay, now this is just a point what you have to mention. Suppose if there is a log beside that, this is the original vector that I'm talking about, whereas this is the point or the position vector that I'm talking about, right? So there are two things. Both are mentioned in IJK forms only, but we need to understand whether it is a point or a vector. If it is a point doesn't make any sense in vectors, remember that. If it is a vector only, we can do some operation in this chapter, right? So we need to, we need to understand what they have given us first. So it's a vector length there. It's a vector that is that has got some direction, or it is just a point what we have to make. Now, question number 18, what they said, you just tell me whether it's a point or the vector what they have given us. If the vectors A, B, C constitute the sides of the triangle ABC. So this will be my vector A. I would call opposite to vector B is my vector B, and opposite to the vertex C is what my vector C. Okay. So let me give this BC as vector A. All right. So let me write them. Right. Now, my question says ABC are these vectors constitute the ABC triangle, and then the length of the median bisecting the vector C. Okay, so vector C, there is some median. It seems, let me say this is CD. This is the median which is bisecting my vector C. That means which is bisecting AB. Right. Now, what do I want? They want the length of the median bisecting. So CD bar, if I get to know what is it. So mod CD bar gives me its length there. Got the point there? So first of all, my intention is to find what is CD bar. So can I say CD bar is CA bar plus AC bar low or AB bar low, half of it. Isn't it? Clear? Half of that. It is just half of that. So observe, this is CD bar. CD bar is CA bar plus AB bar lo half. Or I can also say CA bar is B bar plus AB bar is C bar by 2. Right? So what is this B bar plus C bar by 2? Okay. B bar is minus I plus 3J plus 4K bar plus C by 2 is what? Let me write it directly. That will be, yeah, just by 2 and tell me. 2I bar minus J bar minus 3K bar, right? So when I add them both, that is what my CD bar is. That is 2I minus 1. That is I bar. Next, yeah, plus 2J bar and plus K bar, right? That is my CD bar. Now my question is what is the length of this is what my question is. So that is modulus or the magnitude, that is under root of 1 plus 4 plus 1, that is root 6 will be my answer there. Got the question? Right? So try to understand carefully whether they are the vectors given or the points given. If these are the points given, if these are the 3 points are A, B, C are the points they have given, you have to find out what is AB bar, AC bar and BC bar and then apply the process. Clear? Right, now question number 19. Yes. What's given? You are given A, B, C are 3 vectors given to us and A bar, angle between them. Angle between A bar and B bar is pi by 2 and A dot C is 4. Then how are these relations given? Let me write the question. Right. So as they have given A, B and C given to us and they said angle between A and B is, yeah, pi by 2. So can I just mention cos theta or yeah, A dot B obviously will be 0, isn't it? So cos theta in the sense cos 90, which is A dot B by mod A mod B, right? Now tell me when cos, this is 90, obviously 0. I know that A bar dot B bar equal to 0. I'll apply the condition for A dot B. That is x multiplying just x components, I components, j components and k components and adding, that will be your A dot B. That is x minus y plus 2z, I guess, right? Yes. So x into 1, y into minus 1 plus 2 into 1. Yes, which is equal to 0. This is my first equation framed there. Now coming for the next equation, that is coming from A bar dot C bar equal to 4 is already given to me. So what is A dot C? That is mod A mod B and cos of angle between A and C. Oh, why do I need this? I do not need this, isn't it? I am already having A and C. Just take the dot product, okay? Right, A dot C. So A with the C, that is xi plus 2y, I guess, right? Oh, I, J, K isn't there in C, right? That's it. Equal to 4 is what they said, right? Now solving for these two, what do we get? Let us check, right? Solving for these two equations. Just solve the equations and tell me now. Oh yeah, there is no Z here, isn't it? That is 2z only, right? So solving for x minus y equals 2 minus 2, right? That is my first equation, what I have written. Subtraction minus plus and minus. This is a minus 2, I guess. Hence, this becomes a plus 2. Right, these both gets cancelled. I got my 3y to be equal to 6, which is y equal to 2. Now, when y equal to 2, substitute here your x equal to 0. Right, now the question is, everywhere in your options you find ABC scalar triple product there. That is, it is just the determinant of ABC. So what is it? A is your x, y. Oh, we know the values for them, isn't it? X is 0. Yeah, y we got it to be 2, and that is 2, right? And coming here, B, that is 1 minus 1 and 1. C, that is 1, 2, and 0. Yes, and now you just figure out what this is. So 0 into something. So 1 into 0 minus 4 again. Plus, this is minus 1 into, these both gets cancelled. So 0 minus 4 plus, yes, 1 into, that will be 2 minus of minus 2 plus 2, right? All right. We got it to be 4 plus 4, that is 8 is what we got. Okay, that we didn't get it to be 0. Now coming for whether it is magnitude of A. Now tell me what is magnitude of A. Magnitude of A, x is 0, y is 2. So that is 2j plus 2k. So that is under root of magnitude of A will be under root of 4 plus 4. That will be your root 8. So root 8 square will be 8, isn't it? So obviously we can say that ABC. So box ABC is same as your 8, which is your A bar square, isn't it? Right? That's how you get the conclusion there for that question. Now going with the question number 20. You've got A, B, C. If A plus T, B bar is perpendicular to C. What do you mean by perpendicular? Obviously, whenever you see a word perpendicular, immediately mention that their dot product is 0, right? So now for question number 20, you are given A plus T, B bar dot C bar equal to 0 because these are perpendicular vectors is what they said. Now tell me, is it like A bar dot C bar plus T times B bar dot C bar equal to 0? Now you figure out for what is A dot C. You are given A and C vectors here. A dot C, their dot product plus T times B dot C, B and C also you've got their dot product. Please do mention their dot products. You'll getting some scalar quantities only there. Figure out the value of T. This question I am not solving. You can do it on your own. Going with the question number 21 now. Volume of tetrahedron. So tell me what is a, see, tetrahedron is basically a pyramid. A triangular pyramid is a tetrahedron with the coterminous edges as A, B, C. This is A, this is B, and this is C, right? So these three vectors is what you can talk about. A, B, C are these three, right? This is A, this is B, and this I can say that these are the coterminous edges C. Then the value of, volume of tetrahedron with this coterminous edges, and then the volume of the parallelopiped A plus B, B plus C. Okay, so volume of tetrahedron is basically box ABC. 1/6 of box ABC. Okay, this is 1/6 of box ABC, which is 3. So obviously box ABC will be 18. Okay, so this will be 18. Now what is my question? The question is about what? Find the value of the parallelopipe. So parallelopipe in the sense it's a volume of parallelopipe is just box ABC, right? It is just box ABC. But they said they want to have the coterminous edges, that is A bar plus B bar, B bar plus C bar, and C bar plus A bar. Now, we have already done this in our previous vectors classes. I have already derived what is the box of this, which is 2 times box ABC. So, you can remember it by a formula or you can derive the things. It is the cross product of these two with a dot product of this. When you expand it, you will be ending up with this only. Now, 2 times, what is box ABC, which is 18. So 2 times 18, that is 36 will be your answer here for the 21st question. Right. Yes, now coming for the 22nd question, let A bar and B bar be two non-parallel unit vectors in a plane. And they said alpha A bar plus B bar bisects the internal angle between A bar and B bar. Okay. So this is, let me consider this is A bar and this is B bar. And what they said is this vector is the bisector of this vector. Okay, now? Right. So this is alpha A bar plus B bar is what they said. Right. Then what is alpha equal to is my question. Suppose we have already seen the angular bisectors questions in the previous class, isn't it? So if at all I'm talking about the angular bisector, how do I relate that? So is it A cap plus B cap upon 2, right? That is how I notate my angular bisector of A and B. Okay. Right. Now, so when I'm talking about this as an angular bisector, can I say angle 1 equal to angle 2? Right. So obviously cos theta cos of angle 1, or let me consider theta 1 and theta 2. So obviously cos theta 1 equal to cos theta 2, isn't it? So their dot product should be equal, right? So can I say A bar dot alpha into A bar plus B bar equal to B bar dot alpha A bar plus B bar. Is that clear what I've done? Right? So now multiply them. So alpha into A bar square plus A bar dot B bar equal to, here I've got alpha into B dot A plus B bar square, right? So as I said, these are the unit vectors. Can I say this will be turning out to 1 there, isn't it? Right. So this is alpha, A bar square. It's a unit vector is what they said, hence it is 1. Alpha plus A bar dot B bar minus alpha into B bar dot A bar plus 1 equal to 0. Right. Okay. Oh no, it's minus 1. Okay. Yeah. Just a minute. So that is alpha minus 1. Next, plus A bar dot B bar into 1 minus alpha equal to 0. So, or else if I take alpha minus 1 common, I am left with 1 minus A dot B equal to 0. Right, this is what I am left with. Now, either this is 0 or this is 0. Suppose, let us assume A bar dot B bar equal to 1. If this is 0, then A dot bar B bar is equal to 1, isn't it? So how can you get 1? So 1 is same as writing A dot B and T. So that is mod A mod B into cos of angle between A and B, which is 1. Right. So is it same as writing cos 0 degrees there, which is 1? Right. So the angle between them, it should be a 0 degrees. 0 degrees in the sense they are parallel. So you should have A bar and B bar to be your parallel vectors. But in the question, they have already mentioned that these are two non-parallel vectors. So this case 0 is ruled out, isn't it? So this case of 0 is ruled out. Hence, I am just left over with only alpha minus 1 is 0. Hence, alpha equal to 1 is my final answer there. Clear? So you need to understand why a case is ruled out and why not the other case also, right? Clear. So that's it. So here I've just taken A dot B by mod B because I know anyhow these are the unit vectors. Hence, I can always take them. Their mod is always 1. Hence, I just took here A dot B there and here also A dot B, right? Now going with the question number 23. What is given in the question? Right. So in any triangle ABC, 23rd question. So any triangle ABC, P is the midpoint. This is A, B, and C. P is the midpoint of BC, right? And Q is the midpoint of CA, and R is the midpoint of AB. Now the question is to express AP bar plus BQ bar plus CR bar is my question, either in terms of AB or BC or C, right? Right. So I just took a small thing, A, B, C, B, A1, B1, C1, A2, B2, C2, and A3, B3, C3. So as they said, P is the midpoint. Is it same as writing A2 plus A3 by 2, B2 plus B3 by 2, hence C2 plus C3 by 2. Same is the case with the Q and R also. Just one thing is what I'm doing, rest all you do it. Now AP bar plus BQ bar plus CR bar is my question. Now tell me what is A P bar, right? AP bar. So is it nothing with the difference of these two, right? So now A2 plus A3 by 2 minus A1, right? Comma. BQ bar also the same thing. You do it and tell me, figure out what is your. So all the question is what I have done. You can just go through AP bar. This is BQ bar and this is CR bar. If you just add them, you are getting your resultant to be 0 there, right? Just pause it, just check it. However, you're getting your answer, whether you're writing or not. Now, question number 24, right? The equation of a plane. From here, the equation of a planes, lines, and all these is most important, right? So, most prominent questions are yet to come now. From question number 24 onwards, be very careful at them. Now, equation of the plane which bisects the line joining these two at right angles. See, they said a plane which bisects the line joining. So, the line joining A and B, there is a plane which is exactly bisecting, it seems. Let this be a plane, right? So it is bisecting at point D. Point D is on the plane, let it be. Right. Now I just have to think about, I am given my minus 1, 2, and 3, and 3 minus 5 and 6. So they said if it is bisecting, obviously the midpoint should be lying on the plane. That will be the midpoint there. So minus 1 plus 3, which is how much? 2 by 2, which is 1. 2 minus 5, that is minus 3 by 2, and 3 plus 6, 9 by 2. Now you just have to check this point is a point on which of the four planes. So you are given four options here, 1, 2, 3, 4 planes is options given to you. You just have to figure out which option best suits this point is applicable there. So by trial and error method is what you will be completing that question. Okay. Substitute wherever it is satisfying, that will be your plane equation. Now, question number 25. Right. You are given x minus 2 by 3, y minus 3 by 4, and z minus 4 by 5. This line is parallel to which plane is the question. See, remember one thing always when you are talking about a line. Suppose if this is the line L is what they are mentioning, line L. So in your numerator, whatever point you have, that will be a point on the line. That point is 2, 3, 4. Isn't it? When you have x minus a, x minus b, x minus c, a, b, c is a point on the line. And this 3, 4, 5 are DRs of a parallel line. It need not be on that line. So 3, 4, 5 which are in the denominator, this denominator place occupies the DRs of the line which are parallel to some other line, that's fine. So maybe here you have another line with 3, 4, 5 as the DRs. That is what it means for a line equation. Always in your numerator, the point given is a point on the line, and denominator points need not be on the line. Remember, that's a parallel vector to the line. The DRs of the parallel vector is given denominators, right? Now, question number 25, what does it state? They said this line is parallel to which of the planes? See, remember one thing. When you have a plane here, right? That is your ax plus by plus c equal to cz equal to some constant k. What do you relate with ABC? These are the DRs of normal. These are the DRs of normal to the plane. Normal is the N which is drawn perpendicular to the plane. So your DRs of normal are A, B and C. Okay. Now they said the question is about the line is parallel to a plane. So now think about this is the line L which is parallel to the plane. Obviously line DRs and this normal DRs are perpendicular or not, right? So these are the line DRs and this is the perpendicular DRs. These are the normal DRs. So these should be perpendicular, isn't it? So your DRs of the line are 3, 4, 5 and check out for every option. Suppose you are looking at option A. If at all those two are perpendicular, the dot product should be 0. Okay. Now observe option A. 3, 4, 5. They are the same, isn't it? They are the same, which means they are not perpendicular. So leave that option first. Now check out for your 2, 1 and minus 2. Check out for 2, 1 and minus 2 are the DRs of the normal to the plane from the B. So multiply these two, that is 6 plus 4 into 1, 4. 6 plus 4 plus 5 into 2 minus 10. Yay, we got it. So 10 minus 10, answer is 0. So now we got dot product of the DRs. A1, A2 plus B1, B2 plus C1, C2 is 0 in the sense cos theta is 0 in the sense theta is 90, isn't it? So now we can find that these two are perpendicular in the sense DRs of the line are perpendicular to the DRs of the normal to the plane implies the line is parallel to the plane. So option B will be your answer. Clear? So revisit again, try to understand carefully. So a small concept involved there. Whenever we are talking about a plane, plane equation is ax plus by plus zz plus k equal to 0. So remember one thing, you have normal, this is n, vector n. Normal to the plane has got DRs as A, B and C. Now, when I'm talking about a line has got a point. Let me take x1, y1, z1. And if I have my DRs as P, Q, R of some other line, so what will be this line equation? X minus x1, y minus y1, and z minus z1 upon P, upon Q, and upon R. These are all equal. This is how you frame a line equation. This is your plane equation. Clear? Right. Now going with the next question, that is the 26th question. Now DCs of normal to the plane are 26th question. So 2x plus 3y minus 6z equal to 5. So obviously when this is a plane, normal DRs of normal are 2, 3 and minus 6. The question is regarding what about DCs of this. So DCs in the sense when we are given DRs, obviously 2 by under root of 2 square plus 3 square plus 36. Next 3 by under root of so and so. That part you can do it. Now going with the question number 27, if alpha, beta, gamma are the angles which a line makes with the positive direction of x-axis, cos square alpha plus cos square beta plus cos square gamma is obviously 1. Your L square plus M square plus N square is 1 given L, M, N are direction cosines. Here cos alpha, cos beta, cos gamma are the direction cosines, hence answer is 1 without any confusion, isn't it? Right. Now, question number 28. Alpha, beta, gamma are the direction angles of the vector in the sense they are nothing but the direction cosines. So, cos alpha, cos beta, cos gamma. We know that cos square alpha plus cos square beta plus cos square gamma will be resulting in 1. Right. So, cos square alpha, that is 14 by 15 whole square. Next, plus cos square beta, that is 1 by 3 whole square, plus cos square gamma, that is, I don't know what is the value, I would consider that is some lambda. Lambda would be a better option, right? So lambda square equal to 1. Figure out lambda from here. That's it. There ends your question, right? Now coming with the 29th question there. Now, what is the this is a little lengthy question. If you can make out, you try to understand carefully and do it, or else I'll be helping you. No issue at all. If time permits, I'll be doing. Now go with the 30th question. If x minus 1 by L, y minus 2 by so and so. Now, see, whether we need or not doesn't matter for me. You just have to analyze. This is a given line wherein you have a point 1, 2 and minus 1. Did you understand? That is your x minus a, y minus b, z minus c. That is 1, 2 and minus 1 is the point on the line with the drs of the line as L, M and N. Clear till there? Now this is the equation of a line through the point 1, 2, minus 1 and minus 1, 0, 1. Then what is LMN? They said. Yes. See, it is like you have another point also given here. That is your minus 1, 0 and 1. They said the line equation passes through. The first point is already given. Second point also minus 1, 0, 1. Now tell me, suppose this is point A and B. DRs of AB is same as their subtraction there. So that is your minus 1, that is minus 2. 0 minus 2, that is minus 2. 1 minus of minus 1, that is 1 plus 1, that is 2. So is it same as writing your L, M, N are the DRs there? Right? So minus 1 and 1 also I can represent, or 1, 1 and minus 1 also I can represent, because they are the DRs ratio. That is what you have to check out. So in the four options, which one is matching? I think option B will be matching with your answer there, isn't it? You need not get the exact value there. If you just factorize or if you cancel the terms, you should end up with the answer there, right? Because it's a ratio, you can always cancel, no issue at all. Clear? They are proportional. So 1, 1 and minus 1 will be your answer. See, if I just divide it by 2, I got this, but still I don't find it in my options. Hence, what I have done, I have multiplied by minus 1 all over. Hence, I got 1, 1 and minus 1. There results your question. Right, coming with the question number 31. If the angle between two direction ratios are so and so be 45, what is A? This I'm not doing at all. So what is the angle between the two direction ratios? That is A1, A2. See, this is A1, B1, C1 and A2, B2, C2. So A1, B1 plus A2, B2 plus A3, B3 by under root of A1 square plus B1 square plus C1 square into under root of A2 square plus B2 square plus C2 square will be your cos theta. Clear? Right? So from there you can get it. So you can view it here. I have written the cos theta and what is the angle. So you're given A1, B1, C1 and A2, B2, C2. Just substitute and kill your answer. Now going with the question number 32. Right. So what is the question telling us? You are given point of intersection of the lines. Okay, we need to find the point of intersection of the lines, which is your IPE question, if I'm not wrong. Right? So 32nd question, equate it to some lambda and equate it to some mu, right? So what are the points for the first line? First line, if you observe, your x equal to 5 lambda plus 4, your y equal to 2 lambda plus 1 and your z equal to lambda, right? Next, coming for your second line, your x is 2 mu plus 1, y is 3 mu plus 2 and z, that is 4 mu plus 3, right? Now equating these two, you get one equation, 5 lambda plus 4 equals to 2 mu plus 1. That is my first equation. Now equating y and y, 2 lambda plus 1 is 3 lambda plus 2. That is my second equation. Finally equating z and z, lambda equal to 4 mu plus 3, right? Now just the process is what I'm going to tell you. Rest all you should do it. Solve for these two. These are both linear equations in two variables, lambda and mu only, right? So solve for these two linear equations, you will be getting lambda mu equal to something and lambda equal to something is what you will be getting after solving from the first two. Now, once you got that, substitute this lambda and mu in your third equation. If that LHS equal to RHS, yes, your lines are nothing but intersecting lines and they are intersecting at point. Definitely that point is what you will be getting if you substitute your lambda or mu in any of these equations. If at all they are not satisfied, now what does that mean? So after getting your mu and lambda, you are putting it here. Your LHS is not matching with your RHS. What does that mean? Your lines are like this. They seem to be intersecting, but they are not. Observe when I'm keeping it like this, do you find a gap in between these two? They are not at all intersecting. They are on different planes. These two will never intersect. They both are on different planes altogether. They can never intersect. These such lines are called skew lines. Clear? Which are on different lines, which cannot intersect anymore. So based on that question, you can solve it, right? So lambda and all, you can be able to do that. Now question number 33. Equation of a plane which is parallel to x-axis. Just let me, yeah. 33, right? Okay. They said equation of a plane which is parallel to y-axis. See, observe carefully. This is x-axis, y-axis, and z-axis. So we want equation of a ding ding ding. Where is this equation of a plane which is parallel to y-axis? So your plane should be parallel to y-axis, erect. Okay, 3D figure is what I can draw it like this, but it should not be intersecting your y. It can be intersecting your x and z, but it can never be intersecting your y. Clear with that? Right. So they should be parallel is what they said. Question number 33, right? Parallel to y-axis and cuts off intercepts of length 2 and 3 from x-axis and y-axis. As I said, it can be intersecting on x-axis and z-axis. At x-axis, where is it intersecting? 2, comma 0, comma 0. And at at z-axis, where is it intersecting? 3. That is 0, comma 0, comma 3. Now my question is, what is the equation of a plane in its intercept form? Just like your straight line, just revisit your straight lines. Intercept form, that is just x by a plus y by b equal to 1. That is for a straight line. For a three-dimensional plane. Now what is the equation? X by a plus y by b plus z by c equal to 1. Right. Now your x is already 2 given there. Z is already 3 given there. Y, what is y? That is 0 there. Don't think that your denominator is 0, hence it is not defined. Here, what does that mean? That this y factor will not be there at all in your question because it is nowhere intersecting on y-axis. They said it's parallel to y. If it is parallel like this, see, let this be your y-axis. This is my plane, what I'm talking regarding. This plane will be exactly like this, which is parallel. It will never intersect. It will be intersecting your y-axis and z-axis, x-axis and z-axis, but not your y-axis. So this y factor will not be there at all. So what is your equation here? That is my x by 2 plus y by 3 equal to 1. Take the LCM 6, that is 3x plus 2y equal to 1, that is 3x plus 2y equal to 6 will be your equation of the plane. Where do you find? 3x plus 2y equal to 6. Perfect. Option B there, right? Now going with the 34th question. Equation of a plane through 1, 2, 3. 34th question. Equation of a plane through 1, 2, 3 and parallel to the plane. See, whenever you have ax plus by plus cz equal to k is one of the equations of the plane. If at all we want a parallel plane, if at all we want a parallel plane, it is just your A remains A only, B remains B only, C remains C only. When it is passing through some point, A times x minus x1 plus B times y minus y1 plus C times z minus z1 equal to 0 there. So you just substitute your ABC remain the same, that is 2 times. A is your 2, B is your 3 and C is your minus 4. These three coefficients should remain the same because they said it is a parallel definitely. So 2 times x minus your x1, y1, z1 is the point 1, comma 2, comma 3 through which the plane is passing through. So x minus 1 plus b, that is 3 times y minus 2. This is your x1, y1, z1 and plus c, that is minus 4 times z minus 3 equal to 0. Just expand this, figure out what it is, you will be getting your answer, right? Just match up with your answers there. Now going with the question number 35, what it is. Now, the equation of a plane, they said they want the equation of a plane which is parallel to xy plane. So, xy plane parallel, the equation should be of a plane which cuts the length 3 from the z-axis, right? Now, just try to analyze a figure for the given question. Right. So, this is your x, y, and z axis. They said that plane should be parallel to your xy plane. Your xy plane is this. You should have a plane somewhere like this. Okay. This should be parallel to that. That means it should be intersecting only on your z axis. It should not at all intersect your x and y plane. So they said this point where it is intersecting is question number, yeah, at length 3 from z axis. So is it 0 comma 0 comma 3 there? Right? Now tell me again, x by a plus y by b plus z by c equal to 1 is the intercept form of the plane equation. But fortunately or unfortunately, there is nothing intersected on your x and y plane because it is parallel to that plane. It will never intersect your xy plane. Try to visualize it in a three-dimensional view. Right? So this is basically z by 3 equal to 1, which is z equal to 3. That will be your answer, option C there. Right? Now going ahead with the next question, 36. Now what they said is equation of a plane. 36th question now. Right, equation of a plane which bisects the angle between the planes which contains the origin. Oh, see, it is like, this is one open book. Let us think about, okay? This is one open book. So this is plane 1. And this is my plane 2. And what the question is, equation of a plane which bisects the angle between the planes. There is one more plane here, it seems, which is bisecting this. Okay. My drawing is not that correct. Okay, this is exactly bisecting. Let us think about it. Which means, that means angle here equal to angle there here. Okay, na? So it is just like you open your book like this. Okay, right? So these are the two planes there. And if I'm taking another plane in between here, such that their angles remain to be the same. Okay, so that is how you have to visualize that. Okay. Now, they said, what is the angular bisector for your straight lines? It's the same replica of what you can do, right? So, angular bisector for the straight line is it nothing but ax1 plus b, a1x plus b1y plus c1 by under root of so and so equal to plus or minus so and so, right? So, the same thing is what you will do it here also. For the 36th question, your 3x minus 6y plus 2z plus 5 equal to plus or minus 4x minus 12y plus 3z minus 3 by your under root of 9 plus 36 plus 4. Here also under root of 16 plus 144 plus 9. Right? Okay, what about this? This will turn out to be a 7. And here what do I get? This will be 25. Okay, so 169, that will be, this will be a 13 here. All right, now what is my question? Now my question is that should contain origin also. This is just the bisector with a plus or minus. It can be that way or downwards also it can be. But the question is, they said it should contain an origin. So when the question is about containing an origin or any particular point, what we need to do is just substitute the given point. Right now it is origin in your plane 1 and in your plane 2 and tell me what are your answers. It is just about positive or negative what we want. Substituting this origin in the plane 1. Plane 1, you are getting a 5 there. Substituting the origin in the plane 2, you are getting a minus 3. So, if it is opposite sign, obviously negative of the so-and-so will be your answer. If it is same sign, positive of so-and-so will be your answer. This is applicable for any point. So any point you take, if at all they are giving you 1, 2, 3 as a point, that should contain that point 1, 2, 3. If they said so, just to substitute that point 1, 2, 3 in place of x and y in your plane 1, figure out an answer. In place of plane 2, the same 1, 2, 3 you substitute and figure out an answer. Just check whether they've got the same sign or not. If they are of the same sign, plus of something will be your answer. If they are of the negative sign or different sign, so minus of something will be your answer. Now for this question, what will be my answer for this question? As I got opposite sign, minus of something will be my answer. So is it just, I don't consider plus anymore, minus of so and so. So 13 times this first plane cross multiplication equal to minus 7 times, this is minus is still there. So minus 7 times the second plane, you just expand and check out what is your answer in all these 4 options. Clear? I hope process is clear. I'm not solving the whole problem. Wherever required only I'll be doing that. Rest all will be yours. Now going with the question number 37. Right, find the value of k for which these two planes are perpendicular to each other. So what do you mean by planes are perpendicular to each other? Okay, so when I'm talking about one plane here and another plane there, right? If at all these are perpendicular, see, think about I am drawing a normal N1 and from here another normal N2. Tell me, are these normals are also perpendicular? If two planes are perpendicular like this, if you can find that they are at right angles, obviously normal from here and normal from there also will be perpendicular only, isn't it? So DRs of normal to the plane 1 and plane 2. So when I'm talking about question number, which one? 37. Okay. 37, tell me what are DRs of normal 1? That is for the plane 1. Tell me DRs are nothing but the x, y and z coefficients for your plane equation. That is just 3, minus 6 and minus 2. Right? This is DRs of normal 1. For normal 2, what are the DRs? Again, x and y and z coefficients of your plane 2. That is your 2, 1 and minus k. 2, 1 and minus k. That is your 2, 1 and minus k, right? So now when these two DRs are perpendicular to each other, obviously their dot product is 0. Always remember perpendicular dot product 0, right? Perfect. Now 3 into 2, 6 plus minus 6 into 1, that is minus 6 plus that will be your 2k into something, isn't it? Minus 2 into minus k, which is 0. So from here, what are you getting there? So obviously k equal to 0 is what you will be getting there, right? That is your question number 37 done. 38th question. If a point, the point at which the line joining these two intersects the plane, if the plane cuts off intercepts. So always try to analyze a question by drawing a figure, or please try to analyze what is the given question there. Point at which the line joining these 2 points. We have the line joining the points A and B, that is 2, minus 3 and 1, 3, minus 4 and minus 5. They said this line intersects a plane. Let this be a plane. This line is intersecting a plane, right? So what is this plane equation? That is 2x plus y plus z equal to 7, right? Now, if the plane cuts off the intercepts of length 2 and 3 from x-axis and z-axis, question is point at which, where, what is this point is the question? The point at which the line joining these two intersects the plane is so and so. If a plane cuts off intercepts of length 2 and 3 from x-axis and z-axis also they have given. Oh, okay. So that plane will be cutting off intercepts also is what the given condition. Yeah, first of all, we will mention what is the line equation of AB. Right. So equation of AB, line equation anangane, immediately we need to understand what are DRs of AB. So what are DRs of AB? Just a subtraction 3 minus 2, that is 1. Minus 4 minus of minus 3. Minus 4 plus 3, that is minus 1. -5, -1, that is -6. These are the drs. And as it is passing through one of the points is what I'll be choosing. That is x -2, y minus of -3, that is y plus 3, z -1 upon their drs, respective drs, that is 1, -1 and -6. They are all equal is what I'm assuming. So this is my line L equation. Now, once I got the equation, any general point on that equation, can I just mention it equated to lambda? Now, tell me any general point, x equal to 1 in equating these two, that is lambda plus 2. What is y? That is minus lambda minus 3. What is z? That is minus 6 lambda plus 1, right? Now, these 3 points, are these the 3 points, this x, y, z? Can I say that this point P is a point on the plane? Right? So in place of x and y and z is what you can just replace these three, which are in terms of lambda, get the value of lambda. So 2 times lambda plus 2 plus y times so and so. Just substitute and get the value of lambda. There ends your question. Once you got your lambda, substitute in your point and figure out what that point is. Right. Now going for the 39th question there. Now the point of intersection of here also the same way, right? So try to understand the point of intersection of this line and the plane. So equate it to some lambda. So from here x equal to 1 into lambda. From here y equal to 2 lambda plus 1. Z equal to 3 lambda minus 2. These 3 points, these are the points on the plane. So just to substitute in place of your x, y and z, substitute these all lambdas and get the value of lambda equal to what? Once you got your lambda, substitute here, that is your x, y, z point, finish your answer, right? Now question number 40. They said the line is parallel to which plane? This is very, very easy question. Just look at it and tell, isn't it? So you are having, what do you have there? You have your x and y values, but you don't have z, isn't it? So obviously it is parallel to your xy plane only, isn't it? So that line is parallel to your xy plane. Finish. 41st question, equation of a line and a plane be so and so, then whether the line is parallel or perpendicular, what exactly is it? See, line drs. What are the line drs? That is 2, 3 and 2. All the denominators here, 2, 3 and 2 are the line drs. And normal to the plane. So drs of normal to the plane are your 4, -2 and -1. Right? See, this is the line drs and this is the plane normal to the plane drs. Now, if at all they are equal, suppose if I say that these both are equal, if I got these both are equal, which means they are parallel. May not be. Now, just take the dot product. Dot product, let us assume 2 into 4, 8, plus 3 into -2, that is -6, plus 2 into -1, that is -2. Hey, we got it to be 0. When the dot product is 0, are these both perpendicular or not? This normal and the line are perpendicular, isn't it? So, which means, is the line parallel to the plane? Don't think that the line is parallel to the plane. Don't think the line is perpendicular. The line is parallel to the plane, isn't it? Normal is perpendicular to the line implies this line is parallel to the plane. Okay. So therefore, line is parallel to the plane is what your solution is. That is your question number 41. Right. Going with the 42nd question. Right. What exactly is this? The equation of a straight line passing through so and so. Again, so there is a point passing through 1, 2, 3. They said the equation of a line passing through this and this is perpendicular to this plane. What is it? Perpendicular to the plane. So what is the plane? 42nd question, right? All right. X plus 2y, x plus 2y minus 5z plus 9 equal to 0. Right. Now I want the equation of a straight line which is passing through this and perpendicular to the plane. Now tell me, if at all I want the drs of line, that is enough, right? So I already have a point. I want the equation of a straight line here. So in order to get the equation of a straight line, I know it is passing through 1, 2, 3. So x minus 1, y minus 2, z minus 3 is absolutely fine. By something is what I have to make out. For that, if I want the drs of the line, is it same as parallel to drs of the normal? Drs of normal to the plane are 1, 2 and minus 5, isn't it? 1, 2 and minus 5. Are these the same drs of the line as well? Yes. So that is your 1, 2 and minus 5. This is your line equation. Check where it is matching or not. Yes, 1, 2, 3. Your option, your A is matching there. Right. Clear? Right. So all the spears and all, we will be doing it in the next video. Yeah. Right. Going with the 46th question. Length of the vector be 21 and drs be so and so. Then the DCs be what? Now 46th question, observe that. Length of the vector is given to be 21. Okay. DRs are in the ratio 2, minus 3 and 6. So what are its direction cosines? Right. So it's directly is what you can take 2 by so and so, minus 3 by so and 6 by so and so is what you can take it. But check whether that particular vector's length will be 21 or not. That's a serious case what we need to observe. You might go wrong few times. Clear? So for that, how are we going to take? Yes, coming for the 46th question. Yeah, they said a length of the vector be 21. I don't know what that vector is. Let me consider the vector R as my required vector, which is xi plus yj plus zk, right? Oh, it isn't writing. Okay. Now, they said the length of the vector is 21. So that is it under root of x square plus y square plus z square? Y square plus z square is turning out to be 21 there. That is what I have written, right? Okay. Next, what they said, they also said that then the direction, okay, and the drs be, okay. Now let me write what are its drs. Wait a minute. Where is it? It isn't showing there. Okay. So what are the drs? Let me consider 2, minus 3 and 6 are the DRs is what they said. Okay. So is it your x is to y is to z is same as your 2 minus 3 and 6 there. So from here, your x will be your 2k. Okay. Let us assume some other constant there. So y equal to minus 3k and your z equal to 6k. Right. Substitute all these in the above equation. That is under root of 4k square plus 9k square plus 36k square equal to 21. So this is 49k square. That is your 7k equal to 21. Hence your k is 3. Once you got your k is 3, your x is, just substitute there, isn't it? That is 6. Here you have a minus 9. Here you have a 18, right? Now you just rebounce back on your question and figure out your answer, right? So DRs will be 6 by under root of. So these are your DRs basically by under root of so and so. That you'll be ending up with your answer. You will get it. Now question number 47. The point of intersection of the line with the plane. So analyze properly. Draw the figure carefully. Right. 47th question is what I'm talking regarding. Right, point of intersection of the line joining the points. Again, the line joining the points 3, 4 and 1, 5, 1 and 6. So with the XY plane, so try to understand, draw the figure. This is X, this is Y and this is Z. So they said point of intersection of the line joining these 2 points and XY plane. So where is it intersecting your XY plane? This point is what they want, right? So first thing what I need to understand, what is my line equation there? as it is passing through 2 points given there. So tell me, what are the DRs of AB first? So DRs of AB, 5 minus 3, that is 2. 1 minus 4, that is minus 3. 6 minus 1, that is 5. Now when it is passing through a point, so let me consider just one point. That will be line equation is what I am just trying to figure out, right? That is x minus 3, y minus 4 and z minus 5, right? Now what are the DRs there? Yeah, so line equation is what I'm writing there, isn't it? By 2, by minus 3 and by 5. This is the equation of the line. They said it is intersecting my xy plane. So which value obviously is 0 there? If it is intersecting xy plane, it is not at all intersecting your z there, right? So what is the equation of xy plane? So in your xy plane, z has got no dimension there. So obviously equation of xy plane is z equals to 0, right? So now you just equate this to lambda, right? Substitute your value of z. Your z is 5 lambda, my 5 lambda plus equal to 0, which means your lambda equal to minus 1. Right. So you got your lambda equal to minus 1. What's my point actually they're asking regarding your z equal to 0. Right. So lambda equal to minus 1. So what is x value? That is your 2 lambda plus 3. Y is your minus 3 lambda plus 4. Isn't it? And your z is 5 lambda plus 5. Right. Now just substitute your lambda equal to minus 1 here. So what is it? Lambda equal to minus 1. So that is minus 2 plus 3, 1. Lambda equal to minus 1. 3 plus 4, that is 7. So obviously here it is 0, I guess. Right. Okay. What am I ending up with? Oh, the point of intersection isn't matching there. Did I go wrong anywhere? Please check. Anywhere did we go wrong in any calculations? Let us just check quickly. Oh yeah, I got the error. 3, 4 and 1, right? 3, 4. I didn't substitute 1 there. Right. So 5 lambda plus 1, isn't it? So your lambda is minus 1 upon 5. That is minus 1 upon 5 is what you have to substitute here and check your answer. Okay. I hope you understood the process. You will be doing it now. This part is what I am erasing, right? So I got the value of lambda to be minus 1 by 5. Substitute 2 times minus 1 by 5 plus 3, right? So that is minus 2 plus all this. You do it and you get your answer in one of the options is what you will be getting it there. Now going with the question number, right, 48th question. This is a theoretical based question only. Very easy, not to worry. Coordinates of the point P are x, y, z. Direction cosines of OP when O is the origin are. They have given DCs as L, M and N. So you are given OP as R, isn't it? So there is some point P that is your x, y and z already given. This is my OP. And what is OP? That is under root of x square plus y square plus z square. They have mentioned it to be R there, right? Clear. Till here is what I'm having. Now they said DCs are L, M and N. So what do you mean by DCs here? Is it nothing but cos theta, cos alpha and cos gamma there, right? So you got your L value equal to, suppose, yeah, this is R is what I have. Suppose if this is alpha, right? So what is cos alpha? So your cos alpha is same as writing this length, that is x by r. So cos alpha is same as your L. So your L is x by r. Similarly, what do you get? Oh, your options is what you can try out. So your from here, your x equal to LR, right? X equal to LR. Similarly, cos beta equal to y by r. So which is m equal to y by r. So from here you got your y equal to mr. So same way you will be getting your z equal to nr. That is 48. Option C will be your answer there. Next, going with the question number 49, the equation of a straight line passing through ABC. This is very, very easy, very fun to do the question. That is, whenever it is passing through the point and 2 points are given to you, immediately assume this to be your point A and point B. First thing what we need to know for framing the line equation, we need to know passing through which point and dRs. Now dRs of AB is what I am just writing. dRs of AB is just the subtraction of these two. A minus B minus A, that is minus B. Next, B minus C minus B, that is your minus C. Next, C minus A minus C, that is minus A. Right? As it is passing through point ABC, obviously x minus A. Next, y minus b. Next, z minus c. Upon their drs, that is your minus b, minus c and minus a, equate them. This is your line equation. But do you find that in your answers? No, isn't it? You can always cancel your negative sign. So remove that negative sign. After the cancellation of negative sign all over, you will be ending up with x minus a by b, y minus b by c, z minus c by a. That is your option B there, right? Now, going ahead with the 50th question. Equation of a straight line passing through point ABC and parallel to z-axis. So, visualization, what plays a major role here, right? They said equation of a line passing through ABC, absolutely fine. When it is parallel to z-axis, see, observe carefully, this is x-axis, this is y-axis, and this is my z-axis. I want a line equation which is parallel to z-axis. So, I am drawing with yellow clear somewhere here. This is a line parallel to z-axis. This is my required line. Right. So, if it is a line parallel to z-axis, tell me, does it touch z-axis anywhere? Does it touch z-axis anywhere? No, isn't it? So it may be a line like that, or it may be a line like this. So it will be having a chance to touch your y-axis. It will be having a chance to touch your x-axis. But does it have any chance to touch your z-axis? No. So that means what will be your answer? Just look at the question and tell me the answer. So at z-axis, there is no intercept formed. So that might be from here or here. It might be option A or C. Now tell me which one will be your right choice there. Z is anyhow, these two are absolutely fine. But how about that? It can be your option A because it will be touching either your either your y-axis or x-axis, absolutely fine. So that will be your option A there, right? Oh, yeah, just a minute for this question, 50th question. Just a minute. So they said 50th question, right? Okay. So I can take passing through x minus a, y minus b and z minus c. Till here it is absolutely fine. Okay. They said it is parallel to z-axis. So if it is z-axis, what is the equation of z-axis? So you will be having equation of z-axis. On your z-axis, you will be having your x and y coefficients to be 0. Some coefficient for z is what you will be having there, right? So when your z and x and y coefficients are 0, obviously the drs will be 0, 0, 1, isn't it? So that will be your option. Option D will be your right choice there. So please do eliminate the things what we have written earlier. I was wrong at that point. Okay, fine. Got it? So equation of z-axis. Equation of z-axis. So on the z-axis, you'll be having your x value and y values to be 0 and 0. Obviously, your z coefficient only will be there. That will be some point A. If I'm talking about the DRs, obviously 0, 0, 1 will be the DRs. Right? So 0, 0 and 1. Finish. That will be option D. Right. For the question number 51. So what is the length of the perpendicular drawn from the point to the line? Okay. So for the question number 51, there is a point, most important kind, 4, 5, 4, minus 1. This is a point P from which we have a line here, and that line equation is x minus 1 by 2 is y by 9, which is z by 5. right? They said, drop down a perpendicular. What is this distance? The length of the perpendicular is what we need to know. Suppose I'm talking about a point Q, which is any general point on the line. So what is the general point? Equate it to lambda. So that is my 2 lambda plus 1, 9 lambda and 5 lambda. Isn't it? How do I get it? Equating this and this. So 2 lambda plus 1, 9 lambda and 5 lambda are the values of x, y and z, right? Now, my question, see, if at all I got the point Q, which is the foot of the perpendicular, from that point to this line, from the point to the plane is what we have a formula, but from a point to the line, we don't have a direct formula, for which we need to apply a process here. And what is that process? See, drs of line, this is line L, right? So, drs of line L are 2, 9 and 5. Perfect. Now talk about drs of PQ. So what are drs of PQ? Subtract P and Q. So 2 lambda plus 1 minus 5. That is 2 lambda minus 4. Next 9 lambda minus 4 and 5 lambda minus of minus 1 plus 1. So these are the drs of PQ. These are the drs of line. Obviously, they DRC. When these both are perpendicular, their dot product will be 0. So 2 times 2 lambda minus 4 plus 9 times 9 lambda minus 4 plus 5 times 5 lambda plus 1. You equate it to 0. Get the value of lambda. Place in the value of lambda in your point Q. Get the distance between PQ by using x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under the root. There ends your question there, right? Now, coming with the 52nd question, it's a direct IP question. Angle between the lines whose DCs and DRs, these are given by so-and-so relations. So, from L equal to minus M minus N is what you just substitute here, get the value. It's a direct question. What you can do it from your intermediate level question, that is 52nd question. I hope you're clear with all the questions. Please see that you complete each and every question on your own and get back with your doubts. Fine. Bye-bye. Good luck. So next class we'll be going with the level 2 questions. Done.